Hello, welcome to our poster presentation. This is Shijun Yan. This project is done with my advisor, Dr. Jan Hanzinski. We are from the Sensory Motor Control Lab at Louisiana State University. This project is about the potentially deceptive influences of the vertical-horizontal illusion on manual length estimations. The use of vertical-horizontal illusions often bias individuals' visual perception of size, in which people often perceive a longer vertical segment than the horizontal segment. Researchers use different methods to investigate its illusory effects on perception. When looking at different versions of this illusion, stronger effects were observed in symmetrical and upright configurations. While regarding to the effects on movements, our previous findings showed that upper length sensory motor control would be influenced by visual illusion when given the correct performance parameters. The current study was to determine whether manual length estimations of a segment in its perpendicular direction are influenced by illusory cues. We hypothesized that the manual length estimations in this study would be at least partially influenced by this illusion. Now let's take a look at the methods. What is the task? Participants were asked to manually estimate the length of the baseline segment in its perpendicular direction using touch, lift, and touch strategy. They had a start position right here. They had two movement modes, center edge and edge to center. So in the first movement mode, they were supposed to go to the center of the screen, which is the first touch. And then they will point to a place along this long segment that was equal to the baseline, estimated the baseline length. In the second movement mode, they had the same start position. They were asked to point at the intersection of the long segment right here and the edge of the computer screen. And then they estimated the baseline length by pointing to a place along this long segment to match the baseline length. Well, for control trials, they were given a single line instead of this illusion figure, using the same movement pattern touched the two segment ends. Participants were given two baseline lengths, two orientations, and two movement modes, again here. Our variable of interest is displacement ratio. So if the ratio is greater than 1, that means an overestimation. If this ratio is less than 1, that indicates an underestimation. We observed the main effect of the movement direction in some two-way interactions, but the main result is the three-way interactions, which is shown in this graph. The black stands for vertically directed movements for upright configurations. The gray is for horizontally directed movements for rotated configurations. The y-axis represents the mean ratio. What we can see here is that they underestimated for upright and overestimated for rotated only in the center edge mode, which is moving from center to edge. And then the inverted T was smaller than L and MIT. So we did see some difference between the configuration when participants moved horizontally. And then the rest are not significant. So these results suggest differences between movement modes for most configuration and direction combinations. Comparing to the literatures, the difference between two orientations match the influences on perception, and the difference among three configurations partially match the corresponding influences on perception. As for the movement mode, the edge center mode did not differ from control conditions and may be linked to a longer viewing time, which can reduce illusory effects. In addition, we cannot rule out the unknown gaze directions in these two movement modes. At the end, we conclude that our results support a control separation between perception and action for manual length estimations of perpendicular baseline segment.